So, hey folks, good morning, good evening, good afternoon. Hope you all are having a great day. Welcome to this 113th episode of YFTT, Tech Talks by Engineers for Engineers. I am Hemant Bhanawat and I'm the Director of Engineering at Yugabyte. Today we have with us Abhinav Saha. Abhinav joined us as an intern last year. He's going to talk about all the cool stuff that he's working on since last year. So this is the second part of the active session history series that we are having. So yeah, over to you, Abhinav, for the presentation
Yeah.
and the demo.
Hello, everyone. I am Abhinab Saha, a software engineer here at Yugabyte. And today I will be talking about how you can use Ash to debug various scenarios. Right. So, first, I will give a quick recap of last Friday's YFTT by Amit, where he talked about the concepts and architecture of Ash. And then I will jump into the demo where I will show you how you can use Ash to debug some performance issues related to YSQL or some YSQL applications, right? And also we'll also cover some background activities like flushes and compactions. So Ash gives you a historical view of system activity, right? So that answers questions like what was happening in the system, let's say at 3 a.m. yesterday, right, when no one was awake to see what queries were being fired and which clients were firing those queries and all this stuff, right? So internally, what Ash does is it takes a snapshot of the system every second or so, right? And this time duration between two snapshots is configurable, right? And after taking all the snapshots, Ash downsamples it. So what that means is, say for example, there are 200 RPCs in the system, right? And we have configured Ash to select only 100 samples. So then what we are going to do is we are going to randomly select 100 RPCs out of the 200 available RPCs, and each sample is then going to be assigned a sample weight of 2, because right now each sample is worth 2 samples, right? And then Ash takes these samples and stores them in a circular buffer. And again, you can configure how much space you want to allocate here. So that controls how much hours of data you can have, right? And the goal is to eventually persist this data, so it's around for much longer, right? And then we have a YSQL view on top of this circular buffer. So that lets you fire some interesting queries to analyze the data, right? And eventually the goal is to also to have a user-friendly UI and some graphs which will let you easily slice and dice the data. Right? And this feature becomes available as a tech preview in 2.21.1. Right, so as part of the YB active session history view, we have all these columns, right? So we have the sample time. So when the sample was captured, we have some information about the request. We have some information about the wait events, right? So what was the component, if it's a T server event or a YSQL event or a YSQL event, right? Then we have the query ID, the YSQL session ID. We have the client node IP, which client was firing those queries. Right? We have the top level node ID, which T server node the query came to first. Then we have the sample rate and YSQL DB. So we'll get into all these columns more into the demo. Right. So let's jump into that demo. So I already have a cluster running here. Right. So what I'll do is I'll first start a YSQL application. Right. Let's go back to the YSQL session. So let's look at how the raw data of Ash looks like.
So that
So
YSQL application is ingesting some data or reading some data
yeah,
from Yugabyte cluster. What is the
yeah. So that application is just doing some insert queries and some select queries into this Yugabyte cluster that I have running here. Okay, so we have a simple select query here. So it's just the select star from the YV active session history view. And here you can see that I have taken the last 10 samples. Right? I have ordered by the sample time and I've just shown the last 10 samples. So let's see what's the output. So immediately you can notice one thing, that it's not very helpful just like this. Right? We have all this data, but like it's not in a consumable way. Like you cannot get any insight from it, like what was the query and where it is waiting on. Right? You can see some things like, okay, this is the time stamp when the sample is captured. This is the root request ID, and this is the wait event class, the wait event, the top level node ID. But like it's not helpful to debug any scenario. Right? So the true power of Hash lies in the queries itself. So we can write some really powerful queries, and we can join these queries. We can join this view with more views like PG stat statements, right? And some other views which I'll show the demo. So let's look at the next query. Okay, so in this query, I have the query string. I have the information about the wait event. I have the YSQL ID. I have information about the client IP, and I have taken the mean time from PG stat statements. Right? And then I sum up the sample weights, and I do a join with this YB active session history with PG stat statements on the query ID and the DB ID. Right? And I added a filter to just return the data for the last 30 seconds.
So this is basically you are joining PGSS with YB
Yeah.
stat statements. The
YB active session history.
YB active session history to understand what query ID or what query is happening.
What's happening in the system.
Wait event.
Yeah.
Okay. Particular wait event.
Right. So one thing we can immediately see is for the last 30 seconds, only a select query has been running in the system, right? And you can get the whole query ID, but for the demo, I have just just kept this short so that it does not spill over. Right. So we see that it's a select query, and it has an order by clause. So and then something is going on the T server. You can find out what's going on the T server, what's going on the YSQL layer. Right. So let me highlight this portion first. So you will see that the difference between the highlighted rows and the non-highlighted rows is that DB ID is different, the client note IB is different, and the mean time is different. Right. So you can see that there is roughly about 25, 20 to about 23 milliseconds worth of, right. So here you can see this is one major difference between this. And if you notice, there is also another difference. So if I select the last 5 rows, you'll notice that we are doing a lot of IO events here, right? So these events, buff file read and buff file, right? We typically see them when this session does not have enough memory to do some operations, right? So it can be a hash join or an order by clause. So in our case, what's happening is probably we have an order by clause. So we need to sort the data that's coming from DocDB. So while sorting, we do not have enough memory to sort the data, right? So we might be doing some disk. We might be writing the data and reading the data from temporary files to sort it. Right. So here we could probably do two things. One could be to tune your query so that it does not require enough. It does not require that much amount of memory, right? Or you can do what you can do is you can maybe update. You can increase the work memory. Right. So let me just do that.
So just one point there. The difference between the first and second part is the first query set of query is running on one database, while the another is running on another database, and we are seeing some buffered read and write with the second query, right?
Yeah. So I'll just update the work memory in this set. Update the work memory of the cluster. Right. So for that, I'll be using the YBTL CLI tool. And so for updating PG GUC parameters, we have this G flag called YSQL PG conf CSV. So I have passed the work memory here. So I'll just be updating the work memory to, let's say, 32 megabytes. Right, and also this mean time, this comes from pgstat statements, right? And this is from the start of the cluster, right? So to demo how the latency drops, let's also reset pgstat statements, right? So you'll be able to see what's the new mean time after we have updated the g flag. Right, so let me fire the same query again and let's see what's the result. So immediately you will notice two things. One is the latency obviously dropped. Earlier it was 85 milliseconds and now it dropped to 57 milliseconds. Right? And you'll also notice that we don't have this disk IO events anymore. So that was the issue with the application. Right? So with, after increasing the work memory, we can see that the latencies have definitely improved here. So I'll just stop this application and then I'll start a YSQL application. So it will use the YSQL API to fire some queries.
So here the queries are getting executed in YSQL, but we will be querying data inside
Yeah.
YSQL for this.
Yeah. So let's look at the query. Here also I have selected the query string, some information about the wait event. We also have the wait event aux here. So the wait event aux gives you the tablet ID in case of T server samples. Right? And then I have summed up the sample weights. And then, so since this is a YSQL applications, the queries are not going to be uh, in the pgstat statements because they are going to the YSQL layer. So we have a similar view called YSQL stat statements, which we can join to get the query string for the YSQL queries. So I have done a similar thing here. So I've joined the YSQL stat statements on the query ID, and again I have added a filter to show the data only for the last 30 seconds. So we see that we only have a update query running here for the last 30 seconds. Right, so we have two components here. One is the key server components and one is the YSQL components. So let's look at the YSQL first. So in the YSQL, you will notice quickly that this particular wait event, YB client waiting on DocDB, it's the wait event that's taking the most amount of time across the other events, right? We have some on CPU active, on CPU passive events. On CPU active means it's just actively processing the query. And on CPU passive probably means that we are short on threads, right? So to get what's happening in the system, so this wait event means that YSQL layer has sent the request to T server to DocDB, and it's waiting for some response back, right? So to get visibility into what's happening when this we are in this state, we need to look at the T server wait events. Right, so if I highlight the T server wait events, the first thing we'll probably notice is that this locked batch entry log, this wait event is taking the most amount of time. Right, we see 700 samples, 776 samples of this wait event, and this wait event is of time waiting on some condition. Right, and then we have the wait event aux. So all these samples are waiting on this particular tablet. Right, so this wait event we generally see when there is some lock on a row, right? When there is some contention in a log. And since we are seeing a lot of samples for this particular wait event, we can say that, yeah, there is some contention going on for some log, for some row, right? So probably what could happen is like maybe some concurrent sessions are trying to update the same row. Right? So to verify that, we can also print the client node IP. Right, so here I have the query, the wait event component, and this time I have the client node IP, right? And I have again joined Ash with YSQL start statements with the query ID, and it's only for the last 30 seconds. So now we can see that there are five different client IPs which are issuing the same query, right? Or there are five different sessions which are firing the same query, and all these queries are going to the same tablet, and we are seeing a lot of events for a lot of locked batch entry events. So with this, we can probably conclude that there is some, like, probably every session is trying to update the same row in a table, right? So now you might want to check your application, like if that's supposed to do that, or maybe do some other things. So you might also want to say what are the hot tablets right now in the system, right? So in this query, I have the wait event aux and the sample wait, right?
Is wait
From the
event logs always a tablet ID?
no, that's not a tablet ID, but we have not added a wait event aux for YSQL and YSQL samples as of now. So that's why we can say that it's a tablet ID, but it's not going to be like that in the
So for
future.
P server, it is tablet ID. For others, it could be
Yeah,
other thing. That is why it is auxiliary input. Yeah. Okay.
yeah, but
Okay.
yeah. So for YSQL and YSQL events, since we don't have anything as the wait event talks right now, we have them as null. So I have another filter to exclude them. So I have selected these events, and I have also added another filter to show the data for the last 30 minutes. Right. So let's do that. So we can see that there are a bunch of different tablet IDs that are being hit for the last 30 minutes, and this particular tablet, it's being hit a lot, right? From as compared to the other tablets. So if I just scroll up a bit, let's remember what's the tablet ID. It's CF9, right? If I just scroll up a bit, you'll see that it's the same tablet ID. That's this updates are going to, right? So okay, we know what's this tablet is part of some YSQL table, right? Probably this demo table, but we don't know what this other tablet IDs are yet. Right? So as part of Ash, we have also added another view, right, called YP local tablets. So what this does is uh, it returns the tablet information in the current local node, right? So it will return the tablet ID, so which you can use to join this with the we can use okay, you can join this with the wait event docs from active session history. Right? Then you have the table ID, the table type, if it's a YSQL table or a YSQL table. Then you have the namespace name, YSQL schema name, the table name, and the partition key ranges. Right. So now I will just add the next query here. So in this query, first I have selected the query text, right? And I have a case here. So if the table type is YSQL, I select the query string from PG stat statements. Otherwise, if it's a YSQL table, I select the query string from YSQL stat statements. Then I have the query ID, wait event aux, and I have the table type, and I have the namespace name and table name, and again I have summed up the sample widths. Right? And I have three joins here. So the first join is with YB local tablets on the query on the wait event docs. Then I have another join with PG stat statements on the query ID, and another join with YSQL stat statements on the query ID, and another filter to show the data only for the last 30 minutes. Right, so Here you'll probably notice a few things that some in some rows the query text is missing, right? And also some of the query IDs are only a single digit query ID and the others are like pretty big. So what these single digit query IDs means that these are coming from some background tasks, right? So for example, one is for the draft log appender thread, so which writes into the
Uh,
WAL files, write log.
Abhinab, yeah, there is one question. Can you provide real-world examples of how active session history has been used to diagnose issues in Yugabyte deployments?
Yeah, so this feature is still in development, so we have not. I think there was one example, right, where we used Ash to find out that there were some compactions which are like pretty high in some cluster.
Yeah,
But
yeah. Yeah, so I think since this is still this is gonna be released in next week or so, this is not yet tested directly by customers, but at our end, we have done some dog fooding for the internal problems that we have been seeing. For example, there was a customer wherein it was running very heavy workload with a lot of different queries, and then what we saw that when that customer, it was hard to the complaint was simple that my application is slow. I'm not getting the same number of operations that I would expect to get, and that was the complaint, right? And when we ran it, that's against Ash, we were quickly able to figure out that the update queries were locking too much on a particular row, right? So they were like a lot of the update queries were doing the same example that Abhinav was showing. So this was one of the things that we had seen. Right? So that is one thing. The another thing was recently we were hitting a problem where a perf problem, wherein this was an internal bug or something, wherein it was taking a lot of time to do the replication, right? So we were spending. There was a bottleneck when you do a bulk ingest. There was a bottleneck inside the replication logic, right? So all the bulk load data was getting one particular thing, right? So all this thing, so when it came there, we ran Ash. I think Abhinav ran it, and we figured out that it is because of consensus layer that we are having. We were able to figure that out. So yeah, I think that was a consensus layer thing. Abhinav, you were mentioning probably.
yeah,
Okay, keep going.
yeah. So coming back to it, as I was saying, we have some background tasks, right? And these background tasks cannot be tied to a single query. So that's why we don't have a query text step, but we have some fixed query IDs to identify them, right? So for example, one means it's a background thread which is doing the write ahead logs, right? And then we have two which is for flushes, three which is for compactions, and so on, right? And then you'll also notice that for this query ID, we also don't have the query text, right? So what probably happened was did a PG stat statements reset, right? If you remember. So that's why the data for that this query ID is not there in PG stat statements anymore. So you probably don't want to do that. I just did that for the demo to show how the latencies will drop, right? So that's why we don't have the query ID in this case and in this case, right? So here you can see that we already knew that this was the uh, hot tablet, right? This is getting a lot of activity in the last 30 minutes or so. And we can see that some of it is directly due to the query, and some of this is also due to some background operations, right? So now you might want to get visibility to what this background tasks are doing, right? So to answer that question, we can also include the wait event and wait event type in the query, right? So I have the same query. I have selected the query text, the query ID, and so on. And the only difference this time is I have included two more rows, the wait event and the wait event type. right? And everything is same. We have joined with three. We have joined three times, and so on. Right. So here you can see that for each query ID, we have the distribution of variables. Right. So let's pick this example. So this uh, for this background task, you can see that uh, most of the time it's doing disk I/O, right? Wall append. So it's doing the write ahead logs thing, right? And then for this example, we see that the query ID is 2. So this is for flushes. So here you can see that yeah, it's spending the majority amount of time in doing disk I/O, doing write to file. Right? And then 3 is for compactions. So here you can see that yeah, it's doing some disk I/O for some time, but most of the time it's doing some CPU work. Right. So that's how you can get visibility into what the various background operations might be doing in the system.
Okay, 5 minute check, Abhinav.
Yeah. Okay. So going back to the slides. So in this demo, we looked at a few things, right? We first looked at the case of insufficient work memory, which caused the YSQL layer to read and write into temporary files, right? And Ash showed us that there were some disk I/O going on in the system, and that's how we knew that we probably needed to adjust the query or the work memory, right? And then we saw a case where concurrent updates were happening to the same row. So Ash gave us some pointers in terms of the wait event docs as the tablet ID. The client type is there are different clients doing the same query, and then we also have the wait event. We also have the wait events there to help us identify that, because that wait event meant that we are taking a lock, taking a row level lock on doc DB, right? And then we uh, uh, showed how you could use Ash to detect hot tablets, right? We
So,
also have the
Abhinav, there is a question from Yemen.
yeah,
How do we interpret samples in the previous query? Can we assume that it tells us which component was consuming most of the time for query processing?
you cannot do that, because you see the queries are simultaneously exist in two layers, right? So you can think of it like that: the query comes to the YSQL layer, and then the YSQL layer does some processing and it sends it to T server, right? And now, in case of synchronous operations, then you can say that the amount of time that we see on YSQL layer waiting for DocDB, that's roughly equal to the amount of time on T server. But for asynchronous operations like writes, you'll probably notice that the amount of time, the amount number of samples in T server is way greater than the number of samples in YSQL. Why? Because these operations are happening asynchronously, right? We are sending multiple batches of inserts probably, right? So then uh, the number of samples won't be equal, but the number of samples will roughly give an rough estimate of the CPU time that the system is consuming.
I see. So what you are saying, is the samples cannot directly be correlated, may or may not be correlated with the
Yeah,
latency. For example, in selection, you are saying we may be able to correlate, but in case of writes, we may not be able to correlate. But it will actually tell you the amount of processing
yeah,
that
it will
has
be.
happened
Yeah,
inside the system, right, for that particular thing, right? And
yeah,
so I think uh, just a follow-up question to that, since we have this number of events, right, the samples, we can say that this is the time that we are okay, roughly this is the ratio of the time that it is spending in the
yeah,
system, right?
yeah.
Is that a big thing to say? Okay.
Yeah, and you might also want to check what's the sampling interval in that case, right? So let's say if your sampling interval is 1,000 milliseconds or 1 seconds, then you can say that's the number of sample is probably correlate to the number of seconds in the CPU time. But if it's something like 100 milliseconds or so, then you might want to divide the number of samples by 10, right?
Okay,
So
Abhinav, I think, yeah, we are anyway out of time. Maybe you might finish remaining.
yeah, so uh, we also detected hot tablets, and we also had a new view called IB local tablets, which you can use to join with Ash to get more information about the table info and all, right? And then at the end, we looked at the distribution of weight events in some of the background tasks.
Okay. Thank you, Abhinav. Thanks a lot for your time. I think it was a good one, a good presentation. And I think in this two-part series, we have covered how Ash is designed and why it has been designed to how it should be used. Right? The end goal of Ash, probably, Abhinav, is to put these queries in a more consumable format, either in some UI-based tools or anything, but that is future. But right now, it is available for debugging. Right?
Yeah,
Okay. Thank you. Thank you, everyone. Thanks a lot for your time. It was
thank you,
a
everyone.
good